Welcome to the ASQ webinar presentation. I am Papa Baez with ASQ's Body of Knowledge team. Our today is Jim Rooney. Jim is Director of Quality Management and Lean Six Sigma Services for the Public Sector Division of ABS Consulting. He has more than 30 years of experience in quality, risk assessment, and process safety management for many industries, including the chemical process, pharmaceutical, petroleum, medical device, and nuclear power industries, just to name a few. Jim is also very active at ASQ, to say the least. He's a fellow and holds 10 ASQ certifications. He currently serves as the treasurer for the ASQ Board of Directors. In July, Jim will assume the position of President-elect for ASQ. And he'll be sharing the first in a two-part series on the most searched and popular topics on ASQ's website, root cause analysis. And so, without delay, let me pass this over to you, Jim.
Hello. Today is part one of a two-part series on root cause analysis. Part will be more of a philosophical bent. We'll be about what is root cause analysis, why I should perform a root cause analysis, what shape human performance, and how performance is controlled. The portion, which we'll record in a week or so, will have a much more practical bent. About how to collect data, the various analysis tools that are available for root cause analysis, how to generate recommendations and make recommendation management. I like that with a little bit of terminology, just so we're all using the same words to mean the same things. Is accident, adverse event, loss event. As we're describing here is an unplanned sequence of events that results in personal injury, environmental insult, reliability impacts, and or quality non-conformances. The second is, this is an unplanned sequence of events that could reasonably have resulted in an accident or severe consequences. Our third incident, which is of accidents and near misses. To sum up this slide, an incident is an unplanned sequence of actions and conditions that results or could have resulted in consequence for a system stakeholder. Now, why bring in the system stakeholder into the definition? Different stakeholders interested in the performance of your system. They can be in safety, environmental, quality, reliability, security, and even financial performance of a system. So we have different impacts from an incident. We can have a quality impact that has safety implications and financial implications. To cover, the characteristics of incidents are their unplanned, combination of human errors and equipment failures. They hacks on equipment, property, continuity, safety and health, security, and or the environment. Fact is that they generally have underlying causes that create likely situations for people and vulnerabilities for equipment. And they're frequently by precursors that can be detected and investigated. So we usually have near misses that gives an indication that problems. Well, what is analysis? What we're here is a systematic method to investigate an incident or a series of incidents. So a large incident, like fire or explosion, could be a series of small chronic quality problems in our manufacturing process that we want to look at. What we're here is to understand the underlying causes of the incident. What really caused the incident to occur? Not just the superficial equipment failure, but what really caused those equipment failures to happen. Is generate effective corrective actions to prevent and mitigate the incidents. Spend our money wisely. We want to make sure that we understand the incident and that our corrective actions match up properly to the causes. Now, there are people in the audience who are saying, we've never structured analysis and investigation program. We still learn something from our past mistakes. So do we restructure the approach? Should we spend the money? Should we invest the time in performing a thorough investigation? Well, some of our theory is that while you learn something from every incident, even cursory investigation, more can be learned with a structured approach. The structured approach is efficient. You can this level of learning without much additional effort. The bottom is that root cause analysis will allow us to look deeper into our processes and determine the underlying causes. And what we're seeing here is a linkage. Root cause analysis deals with processes, as does quality systems such as ISO 9000. A answer for yourself. Role of performing a root cause analysis at your organization. Second to think about that. Some of the common answers to this question. Obviously, we want to protect the safety and health of workers and the public. We want quality, reliability, security, and productivity. These are established goals and very important goals. But let's talk reality. Some primary goal of performing a root cause analysis is to get us back up and running as quickly as possible. There are particular times, usually when your lawyers get involved, where you're trying to stipulate blame and or liability. But blaming individuals usually doesn't help because those causes are not within the control of the individual. About why to do a root cause analysis throughout the rest of the presentation. When you do your root cause analysis, what are types of recommendations from your current RCAs? I'll give you a second to think about that. I'm betting, and I can use that in most of the classes that I teach, that your common recommendations are training, counting, and supervision, and possibly repair or replacement of broken equipment. Good. They have their place, but sometimes they not get at the underlying causes of incidents. I'll talk a little bit about why that's so. Let's talk about analysis for failures. Why do we perform them? Well, we want to fix the equipment. So the first level of analysis for equipment failures, we're going to go out and repair and replace the failed equipment and restart the system so we can make money again, start making product. Complicated failures, we need to analyze what happened and the equipment failed to have a little bit better understanding. What we're really talking about here is a first level analysis that many companies do is a fix it and forget it approach. Many people know this more as the fly, fix, fly type of approach. Back to the Wright brothers. They'd go for a flight, they'd crash, they'd figure out a little bit about why they crashed, they'd fix the plane, and then they'd fly it again until they crashed again. Many use this type of approach in doing their equipment root cause. How effective is this approach in preventing the next failure? Well, ask that question. Will implementing these recommendations prevent the next failure, especially replacing the equipment? The answer is no, they won't. Let's understand and address why the equipment failure. We've got to understand the underlying human errors that led to the failure. Our maintenance department interrupted this piece of equipment. Routine What preventive were they doing? How was this selected and procured? How did that work? What are the designers of the system and the piece of equipment? What they do that could have led to this failure? All failures can ultimately be traced back to some human error. So fixing the piece of equipment really won't uncover the others. So let's go a little bit here and talk about people. Performance analysis for human errors. Well, we said it. Even if the equipment operates properly, human errors can prevent the system from achieving its goal. People can misstate equipment, inadvertently on, so we need to investigate human errors so that we can identify and correct them also. Do we need to provide a fix-it-and-forget-it approach for human errors? Will that work for us in any type of situation? So let's start this. Let's the person. How are we going to do that? One way, and it's a very common way, is by punishing the person. And there are very many forms of punishment, some overt and some subtle, and we're going to talk about them. We punish the personnel who commit the errors to ensure that they won't commit that error again. So we have a goal. We don't want this bad thing to happen again. We don't want people to make a mistake. So let's punish them to make them understand how important it is to fix the situation. Punishment. We're going to do this again by assigning them the worst jobs, reassigning them to the worst shifts, provide time off, terminating them. So this is going to fix our problem. Now, punishing these people. Source of these punishments needs an attitude adjustment. Time off and lousy work assignments are going to convince this person that they work for a great organization and the employee should care more about it. I'm positive that that's what it is. I know that that employee's improved attitude is going to be contagious, and everybody else's attitude is going to improve also. I'm sure that that's how it'll be. When we terminate the employee, we're going to somebody, and we're going to replace him another, and that person's going to be perfect, and nothing's going to go wrong. Hope we fired somebody who made a mistake. Other workers are going to understand that this is an undesirable behavior, and you really don't want to do it. There are some punishments out there too. If we counsel people, if you had a better safety attitude, if you had a better attitude towards your job, you're just making these mistakes. We're going to prevent it. You know, if people that do it, they wouldn't make this mistake ever again. Procedure, we go back over it in detail so they know what they're supposed to do. Step 1, step 2, step 3. We full to task demonstrations. We ask to demonstrate proper task performance so we can be sure that they really have the skills to do the task. So I'm going to watch you do it. Make sure you know how to do it right. These are punishments when the cause of the incident is unrelated to the solution. I'm not anywhere in improving the performance of my system, eliminating equipment failures, and eliminating personnel performance gaps by punishing people on a routine basis. It just doesn't work. And then, have you ever made a math error? Of course, errors. So, you made that math error. What if I forced you to attend a class on basic mathematics, addition and subtraction? What if I the goodness of math, about how you really need to know your math, and I made you to demonstrate your math skill by passing a test? How do you feel towards the organization that signed these corrective actions towards you? You would feel very charitable, and I don't believe you'd be motivated to do your best work. Again, punishment, whether overt or subtle, does not solve human performance problems. Skew is, how effective have these measures been in preventing incidents at your facility? Counting, training, procedural reviews, term and off. Cases that I'm dealing with clients and their root cause analyses, the recommendations are overused. Their place, but in many situations they're used more as a punishment than as a true corrective action. They're not always bad. All methods are appropriate in some incidents, in some situations. They're effective when there's a little desire to perform the task incorrectly, knowing it will turn out wrong, or lack of knowledge that results in the wrong behavior. So teaching the employee the correct way to do it, showing them the right way to do it, reviewing the procedure truly does work in this situation. So now, the situations where the task was willfully performed incorrectly to help the company. I did it wrong on purpose, okay? Because I'm positive that the task cannot be performed correctly the way they teach me to do it. The worker or the company gets punished for performing the task correctly. It takes way too much time to do it correctly, and my supervisor doesn't like that. The worker gets rewarded for performing the task incorrectly. If I do it incorrectly, things go faster. We're more productive. We make more money. We make more product. So, guys, the way to do it is to take a shortcut. Okay? Analyze these type of situations and understand them. Because, obviously, training is not going to solve it. The employee knows the right way. They didn't do it. Again, people really do develop poor attitudes. They're about the organization or their employees. They're not concerned about safety. They're not concerned about the environment. But my question is, shouldn't we have dealt with this bad attitude long before root cause analysis identified the issue? Where is the first-line supervisor in identifying someone's bad attitude and working with them on that? In some cases, training on how and why to perform the task properly can help. But if they weren't trained, shouldn't we find out why they never got trained? If it's not right, shouldn't we find out why they developed incorrect training in our training department? So we've got to understand the underlying causes of the event and take our corrective actions. So, do these methods work for a typical incident? These are trying to do the job correctly. And this is why in many incidents in the first place, they want to prevent things from getting worse. They want to make sure that we're making money, that we're making quality product, that our production rate is as high as it can be. So in order to on time and within the tools and information available, they take shortcuts and push the limits, believing doing the best thing for the organization. Your employees do not come to work saying, "I do a bad job today." That's just not the case. Your employees are trying to do the right job, the best that they can for you. And sometimes they do take shortcuts, and we need to understand and control those situations. And we're going to spend some time on, is that many factors affect our personnel's job performance through some of those. How effective is the fix it and forget it approach in preventing the next error? Which actions prevent next error. Understand why the human made the error. We need to understand the underlying causes that led to the failure. Because this helps us determine what, if anything, is wrong with the person involved and or the situation they were in. And many times, as I pointed out at the beginning, we put people in error-likely situations, and that's when mistakes and problems happen. That there are some situations when there are things wrong with the individual, and action needs to be taken within the discipline system of your company. But many times, the great majority, we've put our people in error-likely situations. What shapes performance as a human being? Well, there's lots of them. There's lots of factors that influence my performance. I'm going to talk about two kinds of performance-shaping factors. Internal, which are intrinsic to the person, and external, that are really coming from the environment. The interesting thing here is that most performance-shaping factors are within management control. Management can, in fact, modify both internal and external performance-shaping factors. What are some of the internal pieces, the factors associated with the individual worker? Easily modified. Excuse me. We have it's a skill level, knowledge, physical condition. People can out. We can train them. We can go type of on-the-job training to modify their level. There are some internal steps that are very difficult to modify. Personality, overall intelligence, outside the work site, things that are going on at home. These are much outside the control of management. But I ask you, how many of these factors are you addressing in the corrective actions from your analysis? Talking about knowledge of required standards and goals. Are you at least considering the fact that there are stresses outside the work site that may be influencing your employee performance? There are a number of external performance factors. The first category to talk about is situational, and these relate to your general work environment. What hours? Your shift rotation. How are your tools? What state? Are we running site? We do maintenance on site today? Which middle of the year we have to have somebody on call. Recognitions and benefits and their impact on my performance. You can see that there are many things that are within control of the company for performance shaping factors. Again, how many of these factors are you addressing in your corrective actions for your root cause analysis? That is not very many. We also have directions. We have job task instructions. We have written and unwritten procedures. We have communications. We have TAFIC, standards, policies, and administrative controls. Again, these of instructions for performing a particular job. How well written, how well they understood. Addressing in your root cause analysis. I find that people do consider written procedure and some things in job task instructions. But oral communications are really, the same goes for the standards, policies, and administrative controls. We have a category, 10 equipment characteristics. The entire interface. How easy is the equipment? Is and the control display? Are the unit control display display the same units in the procedure. You have to climb a ladder and hang upside down practically to operate a valve. How do I interface with that valve? Things on this list that we need to take into account. Calculus requirements. Human beings are terrible calculators, especially under stress. We don't very well either, especially as the task gets more complex. How are we using these external PSFs in our root cause analysis? Again, are we considering them? A little about the relationships of the performance shaping factors. You see how we have our worker there at the bottom, and there are some personal factors there, are internal factors. The training, the experience, their inherent characteristics on our employee. We have organizational environment there that's impacting our person, so the task characteristics. So come together and on the people. In fast characteristics, there's information moving back and forth between the human being and the system. They take action. There's speed of the person from the system. All at the same time have situational stressors. Emotional, today, from my family situation, my personal situation, my situation at work, how hot is it, how cold is it wet in the plant, what about the situation today, is there a turnout more product today? All these come together to influence our individual. The question to ask yourselves, how many of these factors are you addressing in your root cause analysis? In your adversary, fix it and forget it approach, whether it be for people or for equipment, many factors are not addressed. So the question to yourselves is, how do organizations control these PSFs? Through systems, engineering, maintenance programs, communication practices. There are many ways that our organization can control the PSFs, and we need to understand the relationship between events, between incidents that happen, and the things that the organization can control. The question comes, what should these management systems control? What management system control in our facility, in our work experience? Well, the thing to realize is you can't control everything. You can't foresee every situation, and you just can't write procedures for everything and have equipment in place to deal with every possible situation. So what can you do? What should you control? Those incidents that can cause intolerable pain, whether that's financial, safety, environmental. We need those incidents and make sure we control them. The highest risk. Here we're looking at of frequency and consequence, and determining from that risk how to take action. Here, risk-based decision making to ensure efficient and effective use of our resources in controlling our. Many do proactive analysis to identify these high-risk situations. Some of them they use are for to every quality professional. Has an operability analysis used in the chemical industry, failure modes and effect analysis we've seen in the automotive industry, in healthcare, release-centered maintenance, in power plants. Analysis was used initially by Boeing in the aerospace industry. It moved to nuclear power plants. It's used now for medical devices. There's also a checklist. All of these methods to properly identify high situations whether they're driven, again, by just inevitable consequences or high risk, a combination of higher frequency and higher consequence. So the question to ask you is, which of the following proactive analysis techniques does your organization typically use to properly identify risks? Think about it for a second. One is that higher risk industries, such as chemical process, nuclear power, and regulated industries, food, drugs, cosmetics, in high reliability is necessary. Aerospace, automobiles, these are used an awful lot. In many of these, they're not used various techniques, but if checklists properly many times on complex systems that really require one of the techniques, such as MEA or fault tree analysis. So it's a good idea to go back and look and see what proactive analysis techniques have been used at your facility. We spend all this time on the human performance and analysis. Well, there is a relationship among analyses, operations, and management systems. And in fact, this is a big driver for why we want a good management system. One will need to be ISO 9000 certified. One, individual companies need to have good process safety management systems for their high hazardous chemicals. Proactive analysis up front. We want to identify our significant risks and safeguards to prevent and mitigate associated consequences. We're asking relatively straightforward questions here. Before the plant, before we make the product, what could go wrong, what consequences, what could cause consequences, how likely are these consequences? So we're wanting to learn here how we'll operate our systems and what the primary risks are from the operations. We come out of proactive analysis and use that line information to set up systems. Okay? We want to manage equipment and human behavior. We want to control risk. So we set lots of management systems. How we run our equipment. What are our strategies? What are our administrative processes? How do we develop training? How do we deliver training? How do we ensure that the training is adequate? We screen these. Ultimately, as a result of that management system, we operate the facility, hopefully in accordance with the management systems. Regardless of how well we operate, we're going to have unacceptable failures and inefficiencies. That is of the human condition. So as a result of that, we have our analysis. We did an investigation. We do our root cause analysis. Because we want to find improvements in the safeguards to prevent, mitigate the associated consequences to adequately control the risk. The safety is assured for our employees and the public, that we produce a high-quality product. Ask ourselves some questions. What is wrong? What points of the incidents? What consequences? And what should be made? First, the proactive analysis process. What did we miss when we did our proactive analysis? A certain event, some design flaw. But what changes should we make to the management system to adequately control the risk? So we see active analysis, we feed back information to the people who did proactive analysis about what they may have missed. Again, a good effort in the proactive analysis will identify very many problems and great amounts of improvements that can be done, especially when you're in the design stage. It's the tip of a pencil that's making the change. You're out there moving concrete, digging up lines, installing special equipment as a result of you're just making a change on paper, and it's easy and inexpensive to do. We have information that feeds back to our management system and allows us to improve the management system. And essentially here is a type of plan, do, check, act cycle, where we're planning with our proactive analysis, we're doing our operations, and we're back through and doing reactive analysis and improvement systems. The whole purpose of this presentation has been to emphasize to you that this of root cause analysis is primarily to understand the underlying causes of incidents, and those driven by the system that controls human performance. Human has an impact on our systems, on our equipment. In cases, equipment failures are directly related to errors in maintenance, in design, in selection. Questions of one today, and that's Pablo. But what I thought I would do is talk about some of the general questions that I normally get. The first is, Jim, this sounds really expensive and difficult to do. That is, yes, it can be. If you're investigating an explosion that destroyed a $100 million plant, yes, that's going to be a very expensive analysis to perform. But the goal, and some of it shown in the next lecture, is to tailor our analysis to the risk of the situation, also to the complexity of the situation. It's fine to use a simple technique, which is a checklist or live wires for a simple problem. And if you have people who are experts in a system, a simple system, those things work fine. So then our goal is to not overwork the problem, but match the system to the technique. And also what we're hoping to do here is, as we learn from an incident and couple with the underlying causes, hopefully by fixing the management system, we go in and make a modification and an improvement in our procurement system. It doesn't only prevent the event that happened, it helps prevent other events that may be due to problems in the procurement system. If I diagnose a problem in my training delivery system, if I fix that, it should fix training delivery across the plant. So what we're really trying to do by taking the management system approach is improve the management system and prevent incidents across the plant. The other question I get is, essentially in a number of cultures, I get this question, again, what is the personal responsibility of the employee to do the thing? Isn't that important? And shouldn't individuals be punished? And yes, it's important that people take the responsibility to do the right thing. That are our employees. And as far as punishment of employees, we have this in place for that, and when they need to be used, they should. But before we go down that path, I'd like to be sure that we haven't put the operator in an error-likely situation. We have asked the operator to look at a display that's in pounds mass and then somehow miraculously make a change to kilograms into a computer system by doing calculation in their head. Because when they're under stress, they're not going to be able to do that. So I want to make sure that as a company, I have made the good faith effort to situation employee can be a success. And really that is the whole purpose of root cause analysis, to make it easy for the employee to do the right thing and make it very hard, darn near impossible, for the employee to do the wrong thing. We will move on to a little bit more of a practical bent, as I mentioned earlier. We will talk about action. We'll talk about the various types of data that you want to collect. We're going to go through a number of different tools and give you some pointers on using them. We'll talk a little bit about how an analysis is conducted, doing recommendations. At this, I'd like to turn it back over to Pablo, and I thank you for listening and your consideration.
Thanks for taking the time to share your knowledge on this very popular topic and that wonderful message that you shared about what root cause analysis is really about. For everyone listening to learn more about Jim, check out contact information here. He welcomes emails and comments and questions, even for the next event. And to learn more about ASQ's wealth of knowledge, a full list of articles and podcasts and webinars and tools and templates on root cause analysis and many more topics, go to ASQ's Knowledge Center at www.asq.org/knowledge-center. That will be posting this webinar as well as the next in the two-part series. And again, we hope to see you at the next event.